Hello everyone. Today let's talk about chapter 3, processes. So in this chapter, I'm going to cover the process concept, process scheduling, the operations on processes, the inter-process communication, and at the last part, we will talk about the communications in client-server systems. As we have mentioned in the previous chapter, a process is a program in execution. So from the perspective of process to see the memory space, there are multiple parts of a process stored in this memory space. So let me draw a figure to illustrate the logical view of the memory space. So when we see a memory space of a process from a logical view, the memory address grows from 0 to the highest. At the bottom of this memory space, so we have the text part. Which is used to store the binary code of this process. And the data part is right above the text part, which is right here. For example, the global static variables or the constant variables, they are stored in the data part. And also at the top of this memory space, the stack part is stored there, which is here. Sorry about the handwriting. And also grows downward. So on the stack, the function parameters return addresses, and the local variables are temporarily stored there. So for example, when you call a function, the parameters requested by this function will be temporarily pushed onto the stack. So when the function gets executed, so those parameters will be popped off of the stack. And also within this function, some local variables may be created inside the function. And also those local variables are also pushed onto the stack. So when the function is terminated, and those local variables will be also popped off of the stack and also go away. And the last part stored on this memory space is the heap, which is right above the data part, is here. So if you still remember that we have talked about the dynamic memory management in the C tutorial, so when you want to dynamically request some memory space from the operating system, those memory space, they will be allocated by the operating system from the heap in logical view. And the memory growth direction is from the low to high, which is this direction, which is opposite to the memory growth direction of a stack. So when you finish using those dynamic memory space, so you can call free function to release those memory space back to the operating system so later they can be available for other processes to use later. And also on a CPU, so we have the current status of the process. So remember, we have a very special register on CPU, which is called the program counter. So this program counter will point to the current instructions inside the binary code that will be executed next on the CPU. And also, we have other process registers to store other status and the progress of this process on the CPU. Program is a passive entity stored on the hard disk as an executable file. So on the other hand, process is active running in the operating system. Remember that is the major difference between program and the process. So when the executable file stored on the hard disk has been loaded into the memory, it will become process running in the operating system. And also we have multiple ways to execute a program. For example, we can execute a program through a graphical user interface. We also call it GUI. We use a mouse to double click the corresponding program icon to execute the program. On touch screen, so we may use a finger to touch the program icon to execute it. And also we can type in the program name as a command line in terminal to run the program. So one program can be executed as several processes. So for example, you can open multiple Microsoft Word software in your operating system. So maybe one used for assignment questions and the other one to write the answers. And also when you use a Turing machine to work on some projects, and multiple users actually they can work on the same project through its own terminal to type in the commands. And the multiple terminal copies belong to the different users. During the lifetime of a process executed in the operating system, it can change state from time to time. At the very beginning, when you double click a program, the program is loaded into the main memory, and then it starts from the new state. So when it is allowed to be executed and also admitted to be executed, it will be put into the ready queue and also switch the state from new to ready and waiting to be executed in the CPU. So then the specific scheduler running inside the operating system will decide which process will be running on the CPU. The state will be changed to running. When some event happened, the current process will be interrupted and move to the ready state. As the interrupted event finished, this process will be moved to the CPU immediately, and also the state will be changed to running as well. So during the running state, the process may need to do some I/O to request the device controller to perform some actions. Then the state will be changed to waiting. After the process finishes the I/O or event completely, the process state will move back to ready again. So when the CPU is available, the process will be put on the CPU again and running there. So when the process is terminated, all the assigned resources will be reclaimed back to the operating system and available for other processes to use later. And also remember that at the early stage, so we only have a single processor with a single core inside the computer. Although we allow multiple processes executed inside the CPU, however, actually at most one process allowed to be running inside the CPU. So why I'm saying at most one process, for some certain situation, actually the number can be zero, because when the operating system is running in the CPU, no more processors available for other processes. But since right now we have multiple processors inside the computer, and each processor have more cores, multiple processes can be running in CPUs simultaneously.